What if the key to solving some of Earth's most pressing challenges, like resource scarcity and the growing demand for renewable energy, lies not beneath our feet, but light years away, scattered across the cosmos? Deep space mining, once the realm of science fiction, is edging closer to reality. Imagine asteroids packed with rare minerals essential for cutting-edge technology, or distant moons holding the building blocks of future energy systems. But how do we unlock these treasures in the infinite vastness of space? This is where artificial intelligence steps in, transforming what once seemed impossible into a bold and achievable vision. In this video, we'll explore how AI is rewriting the playbook for space exploration, overcoming the challenges of mining in hostile environments, and opening doors to a new chapter in human innovation. From groundbreaking technologies to the profound implications for life on Earth, get ready to discover how this union of AI and space mining could redefine the future of humanity. Space exploration has come a long way since humanity first gazed at the stars and dreamed of venturing beyond our planet. Think about some of the monumental achievements we've already made. The moon landing in 1969 wasn't just a giant leap for mankind. It was proof that with ingenuity and determination, we could leave our home planet and walk on another celestial body. Fast forward to today, where we're not just looking at the moon, but charting courses to Mars with rovers like Perseverance and planning missions to send humans there in the near future. Private companies, too, have entered the arena with bold ambitions. Firms like SpaceX are revolutionizing space travel, while companies like Planetary Resources have turned their sights to something once thought impossible: mining asteroids. But while these milestones are inspiring, the dream of harvesting resources from space is far from straightforward. Let's consider the challenges. First, there's the astronomical cost, literally. Launching missions into space requires immense financial investment, from developing specialized equipment to transporting it beyond Earth's gravity well. Then there's the logistics. Space isn't just far away, it's unforgiving. Temperatures can swing from extreme heat to bitter cold. Radiation bombards everything in its path, and the vacuum of space demands technologies that can operate flawlessly in harsh conditions, far from human intervention. And even if we could get to an asteroid rich with resources, how would we extract them efficiently and safely? Add to this the lack of real-time communication over vast distances due to the speed of light, and you begin to see how daunting space mining truly is. These challenges have kept the concept of space mining teetering on the edge of feasibility, but that's where artificial intelligence comes in. AI is poised to become the game changer, the missing piece of the puzzle that could turn this dream into reality. How? By addressing the very problems that make space mining so complex. Picture autonomous AI systems capable of navigating spacecraft to distant targets with precision, identifying the most resource-rich asteroids, and even operating mining equipment without the need for constant human oversight. Unlike humans, AI doesn't need food, water, or oxygen. It doesn't get tired, and it can process vast amounts of data to make real-time decisions faster and more accurately than we ever could. When combined with robotics, AI could enable machines to extract minerals, refine materials, and even build infrastructure, all while humans stay safely on Earth, monitoring progress from millions of miles away. This isn't mere speculation. We're already seeing glimpses of this future in the technologies being developed today. NASA has begun integrating AI into its space missions, using it to analyze data from Mars rovers and optimize mission planning. Meanwhile, private companies are investing in AI-driven automation for mining equipment, testing technologies that could one day operate on the surface of asteroids or distant moons. The foundation is being laid step by step to bridge the gap between what's possible now and what was once the stuff of science fiction. So, while space mining presents formidable hurdles, AI may hold the key to overcoming them. It offers the promise of scaling operations, reducing costs, and eliminating many of the risks tied to human involvement. In the next section, we'll dive deeper into exactly how AI achieves this and why its role is indispensable for the future of mining the cosmos. For now, one thing is clear: the marriage of AI and space exploration could redefine what's possible, not only for science but for humanity as a whole. Artificial intelligence thrives where complexity meets vast amounts of data, and in space mining, that's exactly the challenge at hand. Imagine trying to identify a single diamond in a global sandbox. This is the scale of difficulty we face when searching for asteroids or celestial bodies rich in valuable minerals. The distances are incomprehensible, the targets are countless, and the conditions are far beyond anything we encounter on Earth. Yet, AI is proving to be the perfect tool to cut through this immense complexity, revolutionizing how we identify resource-rich targets in space. At the heart of this transformation is AI's ability to analyze astronomical data on a scale no human team could ever manage. Space agencies and astronomers continuously collect massive amounts of information through telescopes, satellites, and space probes, capturing everything from light spectra to orbital trajectories of asteroids. AI-powered algorithms can process this data at remarkable speed, identifying patterns and anomalies that hint at the presence of valuable minerals. For example, machine learning, a subset of AI, can be trained on known mineral composition data from Earth to recognize similar patterns in celestial bodies. By combining this with advanced spectral analysis, which studies how light interacts with a surface to reveal its chemical makeup, AI can determine the composition of asteroids millions of miles away, down to whether they contain high concentrations of platinum, gold, or rare earth elements essential for our modern technologies. Let's take a closer look at how this works. When light from a star or the sun strikes an asteroid, some of it is absorbed while the rest is reflected back. Different minerals interact with light in unique ways, leaving behind a spectral fingerprint. AI systems equipped with machine learning algorithms analyze these fingerprints, cross-referencing them with known chemical signatures to identify what the asteroid is made of. This process, which would take a human astronomer years to complete for just a small fraction of the data, can be done by AI in a matter of hours or even minutes. Current technologies like NASA's AI-enhanced telescopes are already making strides in this field. For instance, the NEOWISE mission uses AI to sift through thermal data to identify objects that might be rich in resources. Meanwhile, private companies are developing similar AI tools to prioritize promising space mining targets, ensuring that future missions focus on asteroids that offer the highest potential return on investment. But it doesn't stop there. AI doesn't just identify which asteroids are worth exploring, it also calculates the logistics of reaching them. By analyzing orbital dynamics, AI can determine the most energy-efficient routes to intercept these celestial bodies, factoring in their size, speed, and distance from Earth. This level of precision is crucial because space missions are inherently high risk and high cost. Without AI, the margin for error would be slim, and mining operations could waste years chasing targets with little or no value. With AI-powered guidance, humanity can be far more strategic, focusing time and resources on the most promising opportunities. Looking ahead, future AI systems are likely to become even more sophisticated. Imagine telescopes equipped with real-time AI decision-making capabilities, able to autonomously identify and categorize new asteroids as they're discovered. Or consider the potential for AI networks to collaborate globally, pulling data from multiple observatories and satellites to create a comprehensive map of resource-rich targets across our solar system. These advancements would not only accelerate space mining efforts but also make them far more efficient, maximizing the return on every mission launched. Ultimately, identifying the right targets is the foundation upon which all other space mining activities depend, and in this sense, AI is indispensable. It brings the speed, precision, and problem-solving capabilities needed to operate in the vast, complex environments of deep space. In the next section, we'll explore how AI's role doesn't end with detection. Once resources are identified, the challenge shifts to exploration and extraction, and AI is just as essential in overcoming those hurdles. Once the ideal asteroid, moon, or planetary surface has been identified using AI, the next challenge is figuring out how to extract those valuable resources in the harshest environment imaginable. Enter AI-powered robotic systems, autonomous technologies built to perform tasks that would be not only impractical for humans but also outright impossible. These systems represent the cutting edge of space exploration and have the potential to revolutionize how we mine the resources of distant worlds. Let's start with the basics. In space, humans can't operate heavy machinery in real time as we do on Earth. Communication delays, especially in deep space, can range from several minutes to even hours, depending on the distance. This makes remote control virtually useless for mining operations. That's where AI steps in. By giving robots the ability to think, learn, and adapt independently, we can overcome this delay. AI-powered robots don't need constant instructions. They can autonomously navigate rough terrain, identify mining opportunities, and even troubleshoot equipment failures, all without human intervention. Take NASA RASA Robot, for example, short for Regolith Advanced Surface Systems Operations Robot. This compact yet powerful prototype is designed to excavate and transport regolith, a loose layer of soil found on the surfaces of the Moon and Mars. Equipped with advanced autonomous capabilities, RASA evaluates its environment, plans optimized paths, and adjusts its operations based on real-time conditions. Its lightweight design and counter-rotating drum system make it ideal for working in low-gravity environments where traditional digging methods wouldn't function effectively. Imagine deploying fleets of RASA-like robots on the Moon, excavating soil rich in helium-3, a rare isotope with future potential for clean energy. But this is just the beginning. AI-powered robotic systems are advancing far beyond single units. One exciting innovation is the concept of swarm robotics. Picture hundreds, even thousands of small robots working together in coordinated networks. Each robot in the swarm is equipped with AI to carry out specific tasks such as drilling, hauling, or sorting materials, while communicating with the rest of the swarm to create a synchronized workflow. If one robot encounters an issue or breaks down, the rest can adapt, redistributing tasks to maintain efficiency. This approach not only increases reliability but also reduces mission risk as tasks are no longer dependent on any single machine. AI-driven drilling systems are another game changer. Unlike traditional drills, which require frequent human monitoring and adjustments, AI-based drills use sensors and machine learning to adapt to the unique properties of alien terrain. For instance, they can detect variations in material hardness or temperature and adjust their speed and pressure accordingly. This ability to self-optimize is critical when dealing with unpredictable surfaces composed of rock, metal, or ice, conditions far removed from the stable environments on Earth. In fact, prototypes like the Planetary Volatiles Extractor are already being tested to extract frozen water from lunar regolith, a key step toward sustaining long-term missions. These technologies also shine in overcoming unforeseen challenges. Imagine a robotic mining unit encountering an unexpected boulder in its path or dealing with a sudden equipment malfunction. Without immediate human assistance, these could be mission-ending problems, but AI adds resilience to the equation. Through machine learning and onboard diagnostics, these robots can find solutions in real time, like recalibrating their paths around obstacles or performing emergency repairs using spare parts. This adaptability, essential for operating in remote and hostile environments, ensures that mining operations can continue even in the face of unpredictable setbacks. When combined, these technologies form the backbone of autonomous mining on distant worlds. From precision drilling on an asteroid to coordinated swarm excavation on a distant moon, the integration of AI and robotics enables operations that humanity could not otherwise achieve. And this isn't just about extracting valuable metals, it's about survival and expansion. Mining water, for example, isn't only crucial for drinking. It can also be split into hydrogen and oxygen, providing fuel for spacecraft and creating a sustainable presence in space. This capability is essential for mining in deep space, where keeping humans on site is prohibitively expensive and dangerous. AI-powered robotic systems represent a bold leap forward, transforming what would be an insurmountable challenge into a feasible, scalable operation. Next, we'll explore how these mined resources could fundamentally reshape industries on Earth and power humanity's journey toward becoming an interplanetary species. The challenges of deep space mining are as vast and daunting as the cosmos itself. Imagine machinery operating in temperatures that can swing hundreds of degrees between searing heat and bone-chilling cold, or in microgravity environments where traditional tools and methods simply won't work. Add to that the constant threat of radiation, which can damage both equipment and digital systems, and the immense physical distances that massively delay communication between Earth and mining sites. These factors make deep space mining one of the most complex engineering problems humanity has ever faced. But artificial intelligence is proving to be the cornerstone of solutions, offering innovative ways to overcome these challenges and push the boundaries of what's possible. One of the major hurdles is ensuring mining equipment remains operational in such extreme conditions. In deep space, repairing equipment isn't as simple as sending a maintenance crew. It could take years or even decades for human support to arrive. This is where AI-powered predictive maintenance becomes indispensable. By leveraging machine learning algorithms, onboard AI systems can monitor machinery in real time, analyzing a constant stream of data from sensors embedded throughout the equipment. These sensors track factors like temperature, pressure, vibration, and wear on moving parts. The AI uses this data to predict when a component is likely to fail, allowing repairs or adjustments to be made proactively before a breakdown occurs. For example, a robotic drill operating on the surface of a distant asteroid might detect subtle changes in its torque levels, signaling that a bit might be nearing the end of its lifespan. The AI can then signal for an automated replacement, ensuring uninterrupted operations. This approach not only minimizes downtime, but also reduces the need to carry excessive spare parts, saving precious weight and resources. Another critical challenge is navigation. Mining operations in space require precise movement and positioning in environments riddled with unknowns. Think asteroid surfaces littered with unexpected craters or loose, uneven regolith. Traditional navigation systems rely heavily on human input, but communication delays in deep space make real-time guidance impossible. AI, however, excels at autonomous decision-making. Using advanced algorithms, AI can process inputs from a range of sensors, such as cameras, LiDAR, and radar, to map the surrounding environment in real time. It then calculates the best paths for robots and machinery to take, avoiding hazards and adapting to changes on the fly. For instance, if an excavation robot unexpectedly encounters a patch of loose soil, AI can instantly adjust its movements to prevent slipping, ensuring the mining process continues efficiently and safely. The same principles apply to landing spacecraft on small, fast-moving asteroids, where even the smallest miscalculation could mean disaster. AI-powered navigation systems are capable of making split-second adjustments, ensuring pinpoint accuracy in these high-risk maneuvers. Optimizing resource extraction methods is another area where AI shines. Extracting valuable materials from asteroids or planetary surfaces isn't just about digging. It's about doing so efficiently and sustainably. AI can analyze the composition of a mining site in real time, determining the best tools and techniques to use based on the mineral makeup and environmental conditions. For example, an AI system might identify that a section of an asteroid contains a high concentration of rare metals but is mixed with a brittle rock layer. It could then direct robotic machinery to use precise laser mining techniques in this area, minimizing waste and maximizing the yield of valuable material. Additionally, AI algorithms can optimize energy usage during the mining process, a critical consideration in space where power sources are limited and every watt counts. Before any of this happens, though, robots and AI systems need to be trained to handle these hostile environments, and that's where AI-powered simulations come into play. Engineers create sophisticated virtual models of the surfaces of asteroids, moons, and planets, incorporating everything from gravity levels to radiation exposure. Robots equipped with AI are then tested within these simulations, learning how to react to various challenges and refining their decision-making processes long before they're deployed in space. Think of it as a kind of cosmic boot camp where every possible scenario is accounted for. These simulations are especially valuable because they allow for iterative learning. AI systems can run through thousands of scenarios in a fraction of the time it would take in real-world testing, becoming ever more adept at handling the unexpected. Perhaps most excitingly, AI is paving the way for new standards of sustainability in space mining. Unlike traditional methods on Earth, which often lead to environmental degradation, AI systems are designed with efficiency and minimal waste in mind. By analyzing data and making precise decisions, they ensure that only the resources needed are extracted, while unnecessary disruption to the environment is avoided. This concept could even inform sustainable practices back on Earth, creating a feedback loop where innovations developed for space mining drive cleaner, more responsible mining techniques at home. Imagine a future where mining operations, whether on Earth or among the stars, leave minimal impact, preserving resources for generations to come. Artificial intelligence is not just solving the immediate challenges of space mining, it's setting the stage for a future of innovation and sustainability. As these technologies continue to evolve, they'll enable us to extract resources more efficiently, adapt to harsh and unpredictable conditions, and reduce our ecological footprint both on Earth and in space. And as we'll see in the next section, the impact of these advancements will ripple far beyond mining, sparking a wave of transformation across industries and reshaping humanity's relationship with the universe. The implications of AI-driven space mining extend far beyond the confines of engineering marvels or space exploration. They have the potential to transform the very fabric of global economies and technological innovation. Imagine a world where the scarcity of rare minerals, which we rely on for everything from smartphones to solar panels, becomes a thing of the past. This isn't just about mining rocks in space, it's about unlocking a new era of abundance, with ripple effects that could reshape entire industries and redefine what's economically possible. Let's start with the sheer scale of resources that could be made available. Asteroids, for instance, are believed to be treasure troves of rare metals like platinum, cobalt, and the rare earth elements that power modern electronics. To put this into perspective, a single asteroid just a fraction of a mile wide, could contain more platinum than has ever been mined in all human history. These materials are critical not only for the devices we use every day, but also for advancing renewable energy technologies, which rely heavily on rare earth elements for wind turbines, battery storage, and electric vehicles. Right now, the scarcity and high cost of these materials are bottlenecks to scaling renewable energy solutions worldwide. If artificial intelligence enables us to harvest these resources efficiently and cost-effectively, we could see a dramatic acceleration in the global transition to sustainable energy systems. Take the electronics industry as another example. The constant demand for smaller, faster, and more powerful devices has driven manufacturers to seek out increasingly rare and expensive materials. AI-driven space mining could flood the market with these vital resources, potentially reducing production costs and making cutting-edge technology more accessible to people across the globe. Think about how this accessibility could close the digital divide, bringing advanced electronics to billions of people who currently lack access. The effects don't stop on Earth. The influx of new materials could fuel humanity's next big leap, establishing permanent colonies on the Moon and Mars. Resources like water ice found on the Moon can be converted into oxygen for life support or hydrogen for fuel. Metals and minerals extracted from asteroids could be used to construct the infrastructure needed for space habitats, spacecraft, or even orbital manufacturing plants. This is where AI shines, ensuring these operations are optimized, reducing the financial burden of transporting materials from Earth, and making space expansion economically viable in a way that was unimaginable just a few decades ago. But the integration of AI isn't just about boosting efficiency, it's about providing the intelligence to strategically manage this influx of resources. Consider that flooding the market with valuable metals like platinum could dramatically affect their prices, destabilizing industries dependent on their rarity. Experts predict that the key to avoiding such risks will lie in using AI to carefully plan extraction and distribution. By analyzing global markets in real time, AI could help regulate the flow of materials to ensure stability. For instance, algorithms could suggest phased release strategies that align with demand, preventing economic shocks while maximizing the long-term benefits of these newfound resources. Economic forecasts hint at just how transformative this could be. Some estimates suggest that space mining could become a trillion-dollar industry within the next few decades, and companies are already racing to lead the charge. The role of AI in this future cannot be overstated. It acts as the linchpin, turning the theoretical abundance of space into a real, sustainable pipeline of resources that can drive growth and innovation on Earth and beyond. However, with such opportunity comes risk. Over-reliance on a few key players or nations in the space mining sector could create new geopolitical tensions or even spark debates about the ethical implications of privatizing celestial resources. In the end, AI-driven space mining represents more than just an economic opportunity. It's a gateway to a technological revolution. By breaking through the limits of Earth's finite resources, it holds the potential to power industries, energize economies, and drive scientific exploration for generations to come. The real question isn't just whether we'll thrive with these possibilities, it's how we'll ensure this bold new era benefits all of humanity. And this challenge will define the next chapter in our journey to harness the power of the cosmos. With great power comes great responsibility, a phrase that resonates deeply when we consider the implications of space mining. While the idea of harvesting resources from asteroids, moons, and even planets holds boundless potential, it also brings forth a pressing question. How do we ensure that this groundbreaking endeavor is conducted ethically and sustainably? As humanity expands its reach beyond Earth, the choices we make now will set the precedent for our future in space. Will this become a new frontier for exploitation and unchecked greed, or can it be a model for responsible exploration and innovation? One of the most immediate ethical concerns is the risk of creating celestial gold rushes. Just as resource extraction on Earth has historically led to environmental destruction, economic inequality, and even conflict, space mining could spark similar issues on an interplanetary scale. Imagine a scenario where only a handful of wealthy corporations or nations control access to these resources, monopolizing vast quantities of rare materials and profiting without oversight. This could lead to a widening gap between those who benefit from space mining and those left behind, perpetuating inequality on a global scale. Additionally, introducing industrial-scale operations to celestial bodies could disrupt what might be delicate and unknown ecosystems. While we currently don't have evidence of extraterrestrial life, the possibility exists, however remote, that mining activities could destroy habitats or alter pristine environments before we even understand their significance. This is where artificial intelligence has the potential to play a pivotal role. AI systems, when designed with ethical principles in mind, could act as a safeguard against reckless exploitation. For instance, AI could monitor mining operations in real time, analyzing data to ensure that activity stays within sustainable limits. Algorithms could track how much material is being extracted, the energy being used, and the waste produced, flagging any practices that exceed predetermined thresholds. These systems could be programmed to prioritize long-term resource management over immediate profits, ensuring that celestial bodies aren't stripped bare in a short-sighted quest for wealth. AI might also enforce compliance with international agreements, such as guidelines set by the Outer Space Treaty, by providing transparent and objective reporting on mining practices, something that could hold corporations and nations accountable. Another ethical challenge lies in the potential for geopolitical tensions. As space mining transitions from theory to reality, questions about ownership, access, and the distribution of resources will inevitably arise. Who gets to decide which asteroids or moons are mined, and who benefits from their resources? Without clear global frameworks, this new industry could lead to territorial disputes, similar to how countries have clashed on Earth over oil-rich regions or fishing zones. AI could help mitigate these issues by offering neutral decision-making tools to manage resource allocation and mediate conflicts. For example, international AI systems could assess resource availability and suggest equitable ways to distribute mining rights, minimizing the risk of power imbalances or clashes. Perhaps one of the most fascinating aspects of integrating AI into space mining is its potential to guide us toward a moral approach to space exploration as a whole. By embedding ethical frameworks directly into AI systems, humanity can establish principles that prioritize collective benefit, environmental protection, and long-term sustainability. These frameworks could include policies like limiting mining to non-habitable bodies or ensuring that the wealth generated from space mining is shared through global initiatives, such as funding for education or climate change solutions on Earth. AI could even help us evaluate the unknown impact of mining on celestial bodies, running simulations to predict potential effects and recommending strategies to mitigate harm. For instance, it might analyze the structural stability of an asteroid to determine whether mining operations could cause it to fracture, potentially creating debris that endangers nearby planets or spacecraft. But AI is only a tool. It amplifies the intentions of those who design and deploy it. Its ability to enforce ethical guidelines depends entirely on the values we choose to program into it. This raises a critical question for humanity. Will we approach space exploration with foresight and responsibility, viewing it as a shared opportunity for progress? Or will we repeat the mistakes of our past, prioritizing short-term gain over long-term equity and sustainability? As we stand on the brink of becoming a spacefaring civilization, the choices we make today will define the legacy we leave for future generations. AI offers us a way to combine technological ingenuity with moral clarity, helping us navigate the complexities of this new frontier. In the next section, we'll explore how adopting these principles might not only prevent harm, but also unlock space mining's potential to truly benefit all of humanity. After all, what we do in space reflects who we are as a species, and the story we choose to write among the stars begins here. Let's dive into some real-world examples of how artificial intelligence is already pioneering the path toward space mining. While the idea of gathering resources from asteroids or the surfaces of distant moons might sound like something from a sci-fi film, it's closer to reality than you might think. Around the world, both public space agencies and private companies are hard at work testing cutting-edge AI technologies in preparation for the challenges of mining the cosmos. These initiatives are laying the groundwork for what could become one of the most transformative industries of the coming decades. Take NASA Resource Prospector project, for example. Though now succeeded by other lunar exploration missions, this initiative set the stage for using robotic exploration to locate and extract valuable resources. The goal of the project was to send an autonomous rover to the moon's surface equipped with tools to identify and mine water ice hidden beneath lunar regolith. Why water ice? It's one of the most critical resources for future space exploration. It can be converted into drinking water for astronauts, oxygen for breathing, and even hydrogen fuel for rockets. AI played a major role in the project by providing the rover with the autonomy it needed to navigate the moon's rugged terrain and make real-time decisions about where to drill. With no human operators to guide it moment by moment, the rover relied on AI algorithms to analyze sensor data, map the landscape, and adapt its movements to avoid hazards like craters or loose soil. Though the Prospector project itself was discontinued, its innovations are influencing NASA's current Artemis program, which aims to establish a sustainable human presence on the moon by the end of the decade. Meanwhile, the European Space Agency, or ESA, is pushing the boundaries of AI in space mining through programs like AI4EO, which stands for Artificial Intelligence for Earth Observation. While this initiative primarily focuses on Earth-based applications, many of the underlying technologies are being adapted for space exploration. AI4EO employs artificial intelligence to analyze vast amounts of satellite data, identifying patterns and extracting insights that would otherwise be impossible to detect. For example, it can pinpoint the mineral composition of planetary surfaces by analyzing spectral imaging data, a capability that's critical for identifying resource-rich locations on asteroids or the moon. The ESA envisions future missions where autonomous AI systems will guide spacecraft to mineral deposits, oversee drilling operations, and continuously learn from their environments to enhance efficiency. By applying lessons learned from Earth observation to extraterrestrial exploration, ESA is proving that the gap between space innovation and practical application is smaller than we might think. Private companies are also stepping up with bold visions that leverage AI to make space mining a reality. Takeoff World, a California-based startup that's developing swarms of AI-powered industrial robots designed for use on Earth, the Moon, Mars, and beyond. Off-World's approach is built around the concept of self-sustaining robotic ecosystems. Each robot in their swarm is equipped with AI that enables it to cooperate with others, sharing data and adapting to challenges in real time. These robots are designed to dig, extract, refine, and even build infrastructure, all without requiring direct human oversight. Off-world is already testing these technologies here on Earth in extreme environments like deserts and underground mines, simulating the harsh conditions they will one day face in space. By perfecting these systems in terrestrial settings, the company hopes to deploy them for future missions that could build the foundation for permanent human settlements on the Moon and Mars. Another major player is ISpace, a Japanese startup with a mission to develop a lunar economy. ISpace has ambitious plans to mine the Moon for water ice and other resources, and their technology heavily relies on AI to ensure success. Their robotic lunar landers and rovers are outfitted with advanced navigation systems powered by artificial intelligence, allowing them to autonomously explore the Moon's surface, collect data, and identify optimal sites for resource extraction. In 2022, ISpace successfully launched its first lunar lander as part of a demonstration mission, marking a significant step toward its goal of enabling sustainable operations on the Moon. The company envisions a future where lunar resources will not only support off-world colonies but also supply Earth with critical materials. Of course, these projects aren't without challenges. Developing AI systems capable of operating in such unpredictable and hostile environments requires overcoming enormous technical hurdles. Even the most advanced machine learning algorithms must be tested and refined to handle the vast range of variables presented by low gravity conditions, extreme temperature fluctuations, and the uncertainty of unknown terrains. But with each new test mission, these technologies come closer to proving their reliability, pushing the boundaries of what's possible in space exploration. These case studies show us that the era of AI-powered space mining isn't some distant dream. It's unfolding right before our eyes, with some of the world's most visionary agencies and companies leading the charge. From NASA, groundbreaking lunar rovers to the swarms of autonomous robots envisioned by Off-World, these projects make it clear that humanity is on the brink of transforming space from a realm of exploration into one of sustainable development. And as we continue to refine AI's role in these endeavors, the impossible seems just a little closer to our reach. Now, let's look even further into the future, toward a vision of humanity as a multi-planetary species, thriving within a fully realized interplanetary economy. Imagine a system where mining operations on asteroids, the Moon, and Mars provide resources not only for Earth but for colonies scattered across our solar system. Picture spacecrafts routinely transporting materials between planets, fueling industries that extend beyond anything we could imagine today. At the heart of this bold future sits artificial intelligence, orchestrating an interconnected web of self-sustaining operations that make this extraordinary vision not only possible but practical. The first step in creating a multi-planetary economy is ensuring that space colonies have access to the materials they need for survival and growth without relying on costly shipments from Earth. AI will play a crucial role in creating this self-sustaining infrastructure. Take water, for instance. It's essential for life support, agricultural systems, and as a raw material for rocket fuel. AI-enabled mining robots could extract ice from the Moon's surface or subterranean reserves on Mars, while automated facilities refine it into drinkable water, breathable oxygen, and hydrogen for energy and propulsion. All of this could happen entirely autonomously, with AI monitoring the supply levels and fine-tuning operations to ensure nothing is wasted. This means colonies could function independently, reducing their reliance on Earth and making space settlement viable over the long term. Now extend this idea across the solar system. As mining operations expand, AI could create a network of resource hubs where minerals and other materials are continuously harvested, processed, and distributed. Think of it like an interplanetary supply chain with AI acting as the ultimate logistics manager. Imagine a fleet of autonomous cargo ships guided by AI, shuttling resources between planets, moons, and asteroid mining stations. These ships wouldn't need human crews. They'd navigate the vast distances of space using algorithms capable of plotting the most energy-efficient routes, avoiding potential hazards like micrometeoroids or high radiation zones. Each shipment would arrive exactly where it's needed, whether that's a colony on Mars requiring buildings, supplies, or Earth needing rare metals to manufacture advanced technologies. The impact of this interplanetary trade could be transformative. On Earth, access to abundant resources from space could put an end to scarcity. Rare metals critical for electronics, renewable energy systems, and medical devices could become readily available, driving innovation and lowering costs. For spacefaring colonies, these resources would enable rapid development, from constructing habitats to setting up manufacturing plants capable of producing everything from tools to spacecraft components. Over time, colonies could even begin exporting unique materials or products back to Earth, creating a two-way trade network and fueling economic growth on a cosmic scale. Beyond the immediate benefits, this multi-planetary economy could serve as the launchpad for humanity's expansion beyond our solar system. Resources mined from space could power the next generation of spacecraft designed for interstellar travel. AI could even manage the construction of these ships in orbit, using materials sourced entirely from extraterrestrial mining operations. By eliminating the need to send supplies and parts up from Earth, humanity could build the kind of massive, advanced ships necessary for journeys lasting decades or even centuries. In essence, AI would be the foundation of humanity's evolution from a single-planet species to a galactic civilization. What's most exciting is that the potential of AI in this future economy truly feels limitless. AI's ability to learn, adapt, and innovate means that it wouldn't just manage the systems of today, it would constantly evolve to tackle the challenges of tomorrow. For instance, if a mining station on an asteroid encountered unexpected conditions, AI could redesign the mining process in real time to overcome the issue. If a colony on Mars faced a resource shortage, AI could reroute supplies or even initiate emergency production to bridge the gap. This level of adaptability means that no matter how ambitious our goals may become, AI will be there, working quietly in the background to make them achievable. This vision of a self-sustaining, interplanetary economy may seem like the stuff of dreams, but the pieces are already falling into place. AI-driven mining, resource processing, and transportation systems are being developed with this long-term future in mind. And while we're still in the early stages of exploration, each breakthrough brings us closer to a reality where humanity no longer sees itself as bound to Earth, but as a species destined to thrive among the stars. The possibilities are awe-inspiring, from sustaining colonies on the Moon and Mars to fueling our quest to explore distant star systems. Artificial intelligence is the key to unlocking humanity's full potential in the cosmos. It's not just a tool, it's the catalyst for a future where the boundaries of Earth are no longer the boundaries of our ambition. And as we stand on the edge of this bold new frontier, one thing is certain: the age of AI and space mining is only just beginning, and the opportunities ahead are as vast and limitless as the universe itself. Deep space mining, driven by the transformative power of artificial intelligence, is far more than a technological advancement. It's a defining moment for humanity. It's about expanding our understanding of what's possible, not only in the realm of innovation, but in redefining our relationship with the universe itself. AI has opened doors that were previously locked by the sheer complexity of space. From pinpointing asteroids rich in rare resources to orchestrating autonomous robotic systems in hostile, alien environments, AI is the linchpin in turning science fiction into reality. It's making the unattainable attainable, and in doing so, it's not just changing how we explore space, it's changing how we view our potential as a species. When we think of space mining, it's easy to focus on the material rewards, the precious metals, water, and minerals that could revolutionize industries back on Earth. But the true impact goes far deeper. With AI, we now have the tools to overcome the immense challenges of mining in space: the extreme temperatures, the microgravity, the communication delays. AI's ability to analyze, adapt, and operate independently ensures that these once impossible operations are not only achievable but sustainable. It turns obstacles, like the vast distances of space and the unpredictability of alien terrain, into opportunities for innovation. And as these technologies advance, they don't just prepare us to extract value from space. They teach us how to do it responsibly, ensuring that this new frontier is explored with foresight and care. The long-term implications are extraordinary. The resources we unlock could power Earth's industries for generations, helping us solve some of the most critical challenges we face, from building sustainable energy systems to revolutionizing technology. But more than that, space mining represents the first steps toward a multi-planetary future. It lays the foundation for human colonies on the Moon, Mars, and beyond, enabling us to live, work, and thrive off-world. It's a future where AI doesn't just assist us, it works alongside us as a partner, helping humanity push the boundaries of exploration and creativity. Imagine a world where scarcity is no longer a limitation, where the resources of the cosmos fuel our boldest ambitions, and where the innovations born in space benefit every person back on Earth. Ultimately, this is about more than mining asteroids. It's about rediscovering what makes us human. The drive to explore, to innovate, to dream bigger than the generation before us. Artificial intelligence has become our bridge to the stars, a tool that not only enhances our capabilities but challenges us to think about how we can use these advancements to shape a better, brighter future for all. As we stand at the dawn of this extraordinary new era, one thing is clear: the possibilities are as infinite as the universe itself. If this incredible journey inspires you as much as it inspires us, we invite you to be part of the conversation. Subscribe to our channel for more insights into the cutting-edge technologies shaping our world and beyond. Share this video with others who are just as curious about what lies ahead, and join us in imagining the possibilities of an interplanetary future. Together, we can explore the extraordinary potential of AI and space mining and uncover what it means for humanity's next giant leap. The future is closer than we think, and it's time to reach for the stars.